going here. So we should be all good and set up and ready to go. I want to start working away at this equivalent payment question. I think we left off here. You can correct me if I am incorrect, but I think I let you guys kind of copy that down. And I would like to work through this question and then get a little head start on working on compound interest. So I kind of want to push our way through the compound interest section, most of it by the end of Wednesday. So please feel free to let me know how your weekend went in the chat. I had a very busy weekend, but I'm very excited today that we have some weather, some nice weather. It is actually quite nice here in Kelowna right now. Sitting for tests. Oh no, it is that time of the year, isn't it? Okay, yeah, midterm season is strong, especially in that business faculty, right? Weekends are a myth when you are retired. What, really? You're just saying that because you got work to do now. Okay, so let's just refresh our memory on this particular question. We have an investment stream worth $10,000 today. So we are given the fair market value of this money in today's dollars. We are going to make equivalent payments, one in a year and one in 2 years from now. Okay, so we have 2 equivalent payments. And after 2 years, the account is going to be fully withdrawn and be at $0. So let's get some timestamps in here. We need a 1 year, we need a 2 year, we need a today bar on our time diagram. That should do the trick for all of the timestamps we need. We have 2 equivalent withdrawals happening, one at 1 year from now and one at 2 years from now. I mean, I'm not retired, Laurel, and I still don't know what day it is. Like, I'm lucky that I'm on time to any of my classes. That's how I feel on any given day. And it's been like that since this whole COVID thing started. It's been it just feels like it's been so busy all the time for those of us that are working. And what we want to do is we want to compare these 2 equivalent payments at today's date. So we're going to be using today as the focal point. So I've put just a little red star. We need to pull back these equivalent payments to today's date. Yeah, basically ruined days. Yeah, it's done something funky. That's for darn sure. I mean, what's important is that you stop watching the mainstream media and that you, I think, just start to begin to live your life again. I think that's something that we all should start at least considering in lieu of all the things that are happening. So anyway, that's a personal opinion. That's not mathematics. You are not here for my personal opinion. You are here for my solution to this time diagram question. Okay, so here is the basic setup. We have 2 equivalent payments. We're going to be finding the 2 fair market values of those 2 equivalent payments at today's focal date. And when we add up those 2 fair market values, that should add up to $10,000. That's the total kind of fair market value today. Now, I think the nice thing about this question is our T numbers are going to be nice and easy. So we have T equals 1, T equals 2. And our rate is given as 4%. So this is what I would consider a very good time diagram. It gives me kind of a nice step-by-step procedure that I'd like to see when I solve a question like this. Okay, I think we are in a good place to start working our way through these essentially 3 calculations we're going to have to do. So in calculation number 1, because our arrows are moving to the left, we have to use the principal value formula. Here's our principal value formula for simple interest. We are going to pretend that this X is a future value. We're going to pretend that it's an amount of money that I have at some point in the future. So that's my future value. And we're going to discount or divide by 1 plus the rate times time. And if we simplify the denominator using order of operations, we get 1.04. So that's, I mean, arguably, maybe I could simplify the decimal a little bit if I wanted to. Maybe let's do that, actually. It might be, I don't know if it's going to make this easier, make this harder. But we can think about this if you want. I know we had a question, I believe, like this on the first test. I can pretend there's a number 1 here, and I can go 1 divided by 1.04. And that's going to give me a decimal number in the numerator, essentially, and kind of get rid of this kind of weird fraction that we have right now. It's going to make, I guess, the division step of the equivalent payments questions a little bit easier. So why don't we do that? Let's see if we get, I don't know, it's not that nice of a decimal number, but I'll write it out for you so you can kind of see my thought process. Okay, so I get that decimal number in front of X. By the way, sneaky trick. If you type in 1.04 and hit the 1 over X button, that should give you this as well. So if you ever want to move a number into the numerator, you can always use the 1 over X button. So that's a kind of a sneaky little trick, or I guess like a little useful tidbit on how to use the 1 over X button. And we're going to go through the same procedure with this second X over here, just changing our T to 2 from 1. So it's going to look like pretty much the same calculation. We're going to have an X in the numerator, 1 plus our rate times time. So we get X over 1.08. And again, I'm, just for the sake, I think, of making this easier in the next step, I'm going to go ahead and I'm going to do the 1 divided by 1.08. And yeah, what we want to do is, try to take as many decimal places as you can. I always recommend if you're going to be converting stuff to decimals, just take as many as you can until that very final answer. And that way we're not going to potentially lose some information along the way. So yeah, I mean, Alexander, if you kind of round to 5, let's say like 5 decimal, let me know how close your final answer is when we do the division. I'm hoping it won't make too much of a difference, but if the larger some of these numbers get, the more kind of fluctuation in like the tens or the hundreds column you can get with these decimal numbers. Okay, so those are the 2 calculations that we need to do up here. The last step is to add these together. So we're going to add these together, and we're going to set that equal to 10,000. Okay, so the last step is that we know that the fair market value today of 1 plus 2 should be equal to 10,000. So it's going to get messy before it gets better. Just give me a moment here. We have to write down these really awful decimal numbers and then add them together, because life wasn't hard enough as it is. $52, $98, $11. So let's see if rounding to all 9 decimal places plays that much of a difference in this particular question. So adding those two decimal numbers up, I get something like 1.88 and some stuff. And then now that we have those like terms connected on the left side, we'll just divide both sides by the 1.8874 number that we have. Yeah, you're welcome, Megan, no worries. And I'm just gonna kind of squeak out our final answer here based on that really big decimal number. Okay, so it looks like I can verify Alexander's calculation. Looks like we're coming out to the same kind of final answer here, $5,298.11. So each of the equal sized payments that we're going to receive from this investment, one that's going to happen 1 year from now, the other one that's going to happen 2 years from now, both of those payments are going to be $5,298.11 big. And maybe one of you can tell me, why is it that when I add these two things together, I actually get more than 10,000? Fair market value today is 10,000, but you're telling me that I get two payments of 5,200, almost 5,300? Wouldn't that be? Yeah, so that's the real key here, right? Is understand that little difference that we're seeing in the fair market value today and the difference we're seeing in our like two equivalent payments in the future, it's all because of interest, right? So these equivalent payments, I expect them to be a little bit larger than 5,000. Oh, Fiona, I just wanted to let you know that after these two withdrawals, there should be $0 left over in this account. So in other words, we're investing $10,000 today. We're going to pull out two equivalent size payments, in 1 year and 1 in 2 years, such that they're the same size. And then after 2 years, there's nothing left in this account anymore. Yeah. So we never really use that $0 in this particular example. It's just to make sure that we have no leftover money in the account. Okay, any other kind of final questions or concerns about working with equivalent payments? Yeah, the zero, yeah, I'm sorry. I don't know if there's a nice way to say like the zero. It's hard to, I guess I could just say the bank account should be empty. I don't know. And also that's the kind of question where like if you're working on test number 2 and you're working on test number 2 during the class time, I'll be able to answer that question for you. I have no problem answering a question like that. So just give me like a little thumbs up, a little yes in the chat if you guys are happy with this particular question and you're ready to move on into the new topic of the day. It's going to be a pretty chill day. It's introduction to compound interest. I have gone through and updated a lot of stuff on Moodle for you as folks are just finishing copying down. So you will, if you need to, you can go back into the last couple of sections of the simple interest chapter on Moodle, and I've updated some of the links to the videos for you. So I've been a busy boy for you over the weekend, getting some videos on the online version of the textbook. So yeah, a bunch of compound interest stuff has popped up, and a bunch of simple interest stuff has popped up if you've missed some of those videos. Oh no, the first video on compound interest had an error in it. Oh, was it my video? Was it one of the online videos, or was it one of the not mine? Okay, that's good to know. I'll have to go look at it and then let you know what that error. Do you remember what the error was? And then that'll let me find it a little bit easier. Oh, wrong number of decimal points. Oh yeah, that happens. Yeah, okay, so I'll go take a look, and if I need to, I can pull that and maybe replace it with a different compound interest. Questions. Just be mindful of that. For those of you that may have looked at the two YouTube videos I posted up, there might be a small error in interest calculation. Well, yeah, I mean, it depends on the interest and how much you're compounding, but yeah, I mean, chances are if you're that far off from your initial investment and you haven't spent like several years. Oh, it's only 1 year, so yeah, that's a little much for a single year. I agree. Okay, what do you need to know? What can you remind me what the big differences are between simple interest and compound interest? I mean, I invest in Bitcoin, so I feel like I'm gambling every day, Braden. I'm continuously gambling. Yeah, so I think that there's a few of you in the chat that are kind of coming up with the same answer. This idea that compound interest, you're going to earn interest on interest in the future. So with simple interest, we really only earn, so capital I here means interest in dollars. We really only earn interest on our principal amount for simple interest. It doesn't matter how long that money stays inside the bank. I only can ever earn interest on the principal amount. But for compound interest, essentially, we're going to see that we use these kind of compounding periods to get work done. We can earn interest on the principal amount, and then essentially we kind of reinvest that new money into the next time step, and that becomes our new principal amount. And so your interest effectively becomes this kind of compounding problem of trying to keep track of all of this future interest. Okay, so let's first talk about how we calculate interest during one compounding period for a compound interest problem. And so if you're curious, there is this kind of terminology we use. It's called compound period. And a compound period essentially is a length of time in which my money is able to earn interest. So this is what we mean by a compound period. And you may have heard some terminology that goes along with this, like monthly or quarterly or biweekly or annually. Like there's lots of different phrases that go along with this concept of compound period. And so the one I've circled here in red tells us how to calculate interest in dollars. So this capital I is interest in dollars. After one compound period, essentially. Okay, P still stands for our initial investment or our principal amount. And then we have this fraction that we're multiplying by. This fraction is often called the periodic interest rate, or it's the yearly rate divided by a frequency number. Is the little scribble after the P a star? Yes, it's going to be a multiplication. Yeah, so P times this fraction. Yeah. Okay, so R is often used to denote the nominal or the yearly kind of rate that we earn for compound interest. And F is a reference to the frequency or the number of times per year that we earn interest. So it kind of refers to the compound periods. So sometimes I call it the frequency number. It's the number of compounds per year, essentially. So frequency of compounds per year. Maybe that will be important for some of you. And so this is technically how we can utilize a formula to get at interest. It's going to be a little bit different from simple interest. So I think it's important for us to kind of look at a couple examples of how this can be used to calculate interest. So let's say we have an initial investment $500 goes through, let's say, 2 years of earning interest. And what we're going to do is we're going to kind of go through the procedure. It's going to be a bit laborious for simple interest because we've done it already. But we're going to go through the procedure of actually going through 2 years worth of earning interest, calculating a future value. And just seeing how simple interest is just slightly different from compound interest. Now, maybe let's do, I don't know, 5% simple interest, and maybe let's do 5% compounded. Now let's go once per year. Okay, so we effectively just get interest at the end of the year in the compounded annually situation. So how are these things? How do they look different? How do they look the same? They're pretty close. They're pretty similar beasts. So let's start with the simple interest case because we know how to think about simple interest with our I equals PRT formula. We essentially know that if we put $500 in at a rate of 5% for 1 year, we should get, how much is that? $25. We should get $25 in interest during that first year. Now, how simple interest is going to be different than our calculation for compound interest is the following. In year 2, I actually can just use the same formula. So in the second year, I'm also going to earn $25 in interest. So the future value of this particular money is going to be $550. And we can verify that using the future value formula, okay? So the future value is going to be our principal amount plus the $25 we earn in that first year plus the $25 we earn in the second year. So we have a future value formula to calculate that. So hopefully that makes sense. That's what we've been kind of talking about for the last week and a bit. That is the simple interest case. Now let's take a look at what happens with compound interest. So let's apply the formula that we saw back here, which is I can be calculated by taking the principal amount and multiplying by R over F. Okay, so we're going to take our $500, which is our principal amount. We're going to take our nominal rate, our yearly rate of 5%. And in this particular example, I've tried to keep things kind of nice and simple so we can compare it easily to simple interest. So our frequency number in this case is 1. We only go through one period where we earn interest if this is a 5% annual kind of rate. So we're going to get 5% annually. And during year number 1, we're going to earn $25, just like we did in the simple interest case. Yeah, Braden, I mean, yeah, we definitely know how to, I'm going to update your formula slightly to match with the textbook. But yeah, we're gonna get to that formula. We're instead of N's, we're gonna use F's, just so it's consistent with the hard copy of the textbook. So what I want you to know is in year 2, what's going to happen in the background is we're going to take our $500 that we started with, we're going to add to it the interest. F is for frequency, yes, to get $525. And this amount of money is allowed to be our new capital P. So that's going to be our new capital P that we use to do our calculation. So in year 2, we essentially are now going to invest $525 and multiply by the same periodic rate, which is 5%. So this is going to come out slightly different. It's going to come out to be $26 and 25 cents. So you can see that the difference happens after that kind of first year or that first compounding period. So these two interest rates are slightly different, right? Because our $25 interest has now made some additional interest in year 2. In fact, it's made an extra $1.25 for us. Okay, so our future value is going to be $500 plus the $25 we earned in year 1 plus the $26.25 we earn in year number 2. So it's going to come out to be what, $551.25. We get an extra $1.25 essentially. How's that? Does that make sense for you guys? Can you kind of see that difference happening? It's super magical. Yeah. It might be the most magical thing I've ever seen. So yeah, so I know some of you have been throwing up some formulas for the future value, and we're going to work towards that. So our goal right now is just to kind of understand, you know, how do I calculate R? How do I calculate F? And how can we kind of update this formula? So when we were looking at simple interest, we started with PRT, and then we kind of upgraded it to the future value formula, right? So that's what we kind of need to do next is how do we upgrade this to a future value formula? I believe a geometric sequence is going to come into play for annuities, but that's not going to be essentially required for the course. So this is going to be a little bit easier for us. It's going to be a little bit easier to see. Yeah, I can hold on to geometric sequence. I can show you in a video in the annuities section how we might use that to our advantage here. This one's, I think, a little bit easier to explain. So after one compounding period, we know that the future value should be the principal amount plus the interest that we earn during that first period where we earn interest. And we know how to calculate I. I is given by the formula P times R over F. And if you're clever, you'll notice that we could factor out P and we get 1 plus R over F. So this is how I calculate the future value after a single compound, after one time period where I'm allowed to earn interest. And what we saw in our last example was as soon as I have this future value, I think about it as the new kind of principal amount, the new investing amount. So after two compounds, we kind of argue that this becomes our new P, essentially. And we can maybe argue that our future value should be this number, whatever it is. And then we're going to apply one more round of interest to it. Okay, so we think about our kind of future value after the first compound as the new principal amount in the second step. And simplifying that by using exponent rules gives us the following. Okay, we can kind of combine those two brackets together since they're the same thing, and we get the principal amount times 1 plus R over F squared. And essentially, we can just kind of keep doing this to find, my future value after any number of compounding periods. So the general rule is after n compounding periods, we would get a future value that looks something like this. So this is a pretty good place, I think, for us to start working on some more examples so you kind of get used to how to utilize the formula. Inside the hard copy of the textbook, they usually write it like this. And we'll talk a little bit about some of these relationships in a moment. But I kind of prefer the R over F method personally. I think it's a little bit more straightforward. Now, this is the other kind of weird oddity about compound interest, and that is whatever rate is shown to you is not necessarily how much you're going to get during each kind of interest calculation. So if it's all dependent on the frequency number, and you can see that right here. So little I is what we call the periodic interest rate. And the periodic rate comes from taking the yearly rate, R, and dividing by the number of times we actually earn interest over the course of a year. So what happens effectively is this R divided by F takes the full rate and breaks it up into a certain number of pieces. And that's actually the interest rate that you get during one of those time steps. And we call that a compound period. So that's my little ditty on that. So in case you're wondering what some of these things are, N here stands for the number of compounds as well. So the total number of times we actually make interest on our initial investment, okay? How are you guys with terminology? So like if I say something like monthly, maybe it's worthwhile to write down this chart. You guys are okay like with that kind of term? Like if I say monthly, if I say biweekly, if I say semi-annually, you know what those frequency numbers are. I think that's a really important thing to understand. You're good on that? Okay, so let's jump into examples then, since it feels like some of you have done a little bit of your bedtime reading. So let's start out with what I would consider to be like nice baby step kind of questions. So Melissa has suggested a periodic rate for us. So if someone can verify that. All right, we have someone agreeing. So yeah, part one, if I ever want to know what the periodic interest rate is, we take our yearly rate and we divide by the frequency number. Here's our yearly rate, 5%, and our frequency number is monthly. So here we know F is equal to 12. So yeah, if we take our 5%, divide by 12, and we'll kind of just keep enough decimal places to make Brian happy. Okay, and yeah, we get like 0.42% or something like that. If you want to put it as 4166, well, that's fine. 417, that's fine. I'm not going to argue. We just need to make sure we have at least 2 decimal places of accuracy. So somewhere in that neighborhood, that's our periodic interest rate. So if you calculate that first, you can utilize this version of the formula if that's helpful. If you don't want to calculate I first, you can use this version of the future value formula, which calculates I along the way. So that's what's important to know here. How do I calculate I? Well, we just take the yearly rate divided, in this case, into 12 equal-sized pieces, and it's one of those equal-sized pieces of size 0.42% that we actually earn every month in interest. Okay, what is the amount of interest in dollars we earn after a single month? So I can use the capital I formula to do that. And I know my initial investment is $1,250. This is a rate of 5% compounded monthly. And can someone just verify Braden's calculation? Is that true? Is it about $5.21? Awesome. Laurel, Fiona, get that number. Amazing. Notice that you can also, since we have the periodic rate, you can also take your 1250, multiply it by I as well. Oops. Let's multiply it by the correct number. Right, if you multiply by I, you should come out to about the same, right? Maybe you can just verify that for me as well. Perfect, yeah. So, whether or not you use R over F or replace R over F with I, it doesn't really matter to me. You end up at the same kind of final solution, but that's the relationship essentially between the period, what we call the periodic rate, and the nominal rate. In our last step here, let's calculate the future value after 3 years of compound interest. So here's our future value formula. At the moment, it is P times 1 plus R over F to the N, where N is the number of compounds that we go through altogether. So Braden is suggesting $1,265.89. Okay, here's where things start to get a little fun. Well, we've already calculated R over F, so that shouldn't be that exciting. So we have 5% over 12. That's R over F. The next thing we need to figure out is, what's this N? I think for the most part, this is where students get a little kind of chuffed up a little bit. Like, what do I use for N? And how do I get that into the calculator? So we need to figure out the future value in 3 years' time. How many times are we going to actually earn interest over the course of 3 years if I earn interest every month? Yeah, N is equal to 36 because we're doing monthly interest over 3 years. Yeah, so N has to be 36. Like I said, that's usually where students kind of get a little bit kind of mixed up is on this power, okay? So I'm just going to highlight, usually it's here or here. That's where students tend to make their mistakes, is these two numbers. So with the power of 36, what do we get? I'm going to actually maybe just pull up my calculator so you can see. So 1451.84, okay. And let's see, I am just going to share my screen so that you can actually see the calculator at the same time. So if you're curious about how to get this into the calculator, you're going to start with your 1250. I just kind of put this all in one big mess. You do have to hit the multiplication button here. So hit the multiplication button and then open bracket. And then you're going to put your 1 plus a bunch of stuff in. Okay, your 5% over 12. Close the bracket. And then we use that y to the x button, right? So we use the y to the x button to get that power of 36 in. So y to the x, 36. And when you hit the equals button, that's what we're going to take as our final answer. So 1451.84. Perfect. So it looks like a couple of you were able to get that one through okay. It's 1451.84. Beautiful. Let's do a couple more examples while we have some time here before class is up. So we'll just kind of focus on the future value formula, and we'll come back and we'll kind of develop some of the other formulas that might be helpful in our next class on Wednesday. So today is about make sure you're happy with future value. That's the important part. Make sure you're happy with the future value. Let's see, midterm number 2 is next week on Wednesday. Oh, goodness gracious, or isn't it, right? Next week, Wednesday, I believe. So yeah, next week on Wednesday is midterm number 2. So October, I'm going to put it October 27th, I believe. Yeah, October 27th. Yeah, we're going to be mostly done the compound interest chapter by the end of class on Wednesday. So we'll have most of the information we need to tackle test number 2. We might have a little bit more material to cover on Monday's class just to kind of make sure we're happy. But uh-oh, 2 quizzes on the same day. Uh-oh. Yeah, 2 quizzes on the same day, that's pretty rough. That was fast, Braden. Just like spending no time at all. He's like, I'm ready for this class to be done. Here's my final answers. Goodbye. Bruh, what are you doing? Okay, bruh. Do you even lift, bruh? Do you even compute? Okay, I'll stop. Let's finish this up. It won't take us too long. I'm just going to kind of finish this up nice and quick for us to kind of get us off at a good time here. So what is the future value of $1,000? So we know we are starting with $1,000. We have a rate of 4.5% monthly. So we know F is equal to 12. We know that R is equal to 0.045. I don't know if you could hear that or not, but it was pretty loud. My window's open because it's so nice, so I hear all the traffic. What should N be? What should N be in this particular case? Okay, so it seems like most of you are happy getting $1,089 and about 90 cents. That seems to be pretty good. So yeah, this is going to be 23. So how many times are we going to earn interest? We're going to earn interest 23 times because we want to figure it out after 23 months. So what did we get? 1,089? Is that what we got? 1,089.90. 1,089.90. Beautiful. Now what about for something like number 2? Okay, we have this compounded weekly. So F is equal to 52. And then we have this information. We have 5 years. So how do I figure out what N is if I'm earning interest every week for 5 years? Yeah. So n is equal to 5 times 52. Is that 260? That's 260. So that's what we need to use for n here. So our future value is going to be our $1,000. 1 plus 0.075 weekly to the 260. That's wild. That's a lot of times to earn interest. Oh, I put it in wrong. I hate that. Whew. Okay, so about 1,472.87. Can someone verify that they're happy with that final answer? Does that make sense? Excellent. Okay, so before you go, here are a couple last formulas that I find helpful. So we kind of talked about this in the last example. This n up here can be replaced with t times f. So I think that's an important thing to note. And that sometimes allows you to calculate n a little bit faster. So here, the number of compounds can be calculated by taking the number of years and multiplying by the frequency number. Okay, so I think this is going to be kind of our drawn out future value formula with all the bells and whistles. So this one hopefully should help you calculate that n number a little bit easier, and then just kind of thinking through how many compounds I'm going to have. So either way, if you're happy just kind of like logically figuring it out, that's cool. But if you need that extra formula, n is always equal to t times f, always, always, always. So it's the length in years times the frequency number. Cool, so that's all I really have to say about future value for compound interest. On Wednesday, we'll come back, we'll talk about rearranging this to maybe find the interest rate, or maybe find the number of compounds or something like that. So we'll talk about some of the other cases that could come up and the formulas that come up for those particular cases. So that's what's on the docket for Wednesday's class. And yeah, casual reminder, just since you're all kicking around copying some stuff, test is coming up on October 27th. Assignment number 3 has been posted as well. You don't have to start working at that until after test number 2. It's not due until November 5th, but assignment 3 has been posted under the annuities section of our course. So you can go look at it if you would like. But yeah, no, I'll bug you about it after the test is done. So Megan, test 2 is covering only chapters 4 and 5. Okay, so only the chapters on simple interest and compound interest from the hard copy of the textbook. So yeah, it won't, why did you get 14? Only 4 and 5. The midterm will be, do you mean 1 to 5 like time-wise? Or do you mean 1 to 5 like chapters 1 to 5? So this midterm will only be chapters 4 and 5. That's it. You won't have any questions on previous material. Yeah, no worries. Alexander, there is a practice quiz I will post for you. There's the practice test that should be posted, the PDF copy of the test. And then I'll try to find some practice questions. I just haven't had a chance I was hoping to have it done over the weekend, but it's on my list of things to do today and tomorrow. So hopefully by tomorrow. Did you get a different answer too, Laurel? So 1,004. Okay, so I'm just going to go through the calculation one more time. Is it 7.75? I think I might have written it down wrong here. Weekly, 5 years. So I'm not sure if it was maybe just because I tried to fool you and I put the number down wrong. Yeah, sorry. So I think I accidentally put 7.5%, right, instead of 7.75%. So I think that's the small error. So sorry, that's my fault, not yours. Yeah, you're welcome. Thanks for looking out for me. I appreciate all of you having my back. No, your calculator is all good. It's all good. It's just me trying to be speedy at the end of class. That's all. Okay, so if you have no other major questions or concerns, I'm going to sign off so I can get that test number 2 going for you guys. Yeah, and I'll see you all on Wednesday. Thank you, Fiona. You have a lovely rest of your day.